The topic is homogeneous equations. So let's do this example. Determine whether the differential equation minus y dx plus x plus square root of xy dy equals 0 is homogeneous. If it is homogeneous, solve it. So let's read the definition. Definition, it says m dx plus n dy equals 0 is homogeneous if there exists alpha such that m of tx ty equal t alpha m of xy and n of tx ty is equal t alpha n of xy. So let's check that. First of all, this is m of xy, so let's write that one down. M of xy is equal minus y, and then n of xy, it's right here, so n of xy is equal x plus square root of xy. So first, let's try to find the alpha. So first, m of, we need to start by the definition right here, m of tx ty is equal, how do we find m of tx ty? M of xy is minus y, that means m of tx ty, it will be minus this coordinate, right? So it's minus ty. Now, what we can do, I mean, if you can see, this is the same thing as t times negative y, right? Why did I do that? Because I noticed that this is my m of xy. So this is equal t m of xy. So let me rewrite it here, m of tx ty. So basically, my alpha here happens to be 1, right? It's the exponent of t. Now let's check n of tx ty. Now n of tx ty is equal, I'm looking here, x means the first coordinate, so I need to use first coordinate, so that would be tx plus, and then square root xy means this coordinate times this one. So tx times ty. Now all we need is some algebra. T times t is t squared xy. Now using algebra, this is the same thing as square root of t squared, square root of xy, which is equal to tx plus square root of t squared is just t, square root of xy. Now I'm going to factor the t, and you can tell this is just n of xy, right? This is n of xy. So basically this is t n of xy, and see, the alpha is still 1, is the coefficient of t. Right, so n, let me write it here, n of tx ty is equal t n of xy. So now we can say, therefore, the equation, the differential equation is homogeneous. The differential equation is homogeneous. So therefore, we can use, once it's homogeneous, you can use y equal ux as a substitution. Once we use this substitution, it will be reduced right here to a separable first order differential equation. So first, let's write our equation. Our equation is minus y dx plus x plus square root of xy dy equal to 0. By the way, y equal to ux, right? This is ux. We rewrite it here. Y is equal ux. All right, so what we need to replace every y, whatever we see y, we need to plug in the ux. We also need to replace dy. So therefore, so this is what we need, y equal ux, and also we need a dy. But how do we find dy? It's just a formula, it's just product rule. So it's a u, product rule of u dx, so it's a u dx plus x du. So this is the only two things we need to plug in. So let's plug in. So let's plug y here. Let's start with this one. So this is minus y becomes minus ux dx plus x plus square root of x. The y again is ux. And the dy is right here. The dy is u dx plus x du, and this is equal to 0. So let's try to distribute. First of all, this is minus ux dx plus, this is just x plus square root of x squared u. Can we just write it as square root of x squared square root of u. But of course, square root of x squared is just x. Let me show all the steps. Minus ux dx plus x plus x square root of u, and then u dx plus x du is equal to 0. This is minus ux dx plus, all I'm doing here is I'm going to write square root of u as u 1/2 before I distribute. U dx plus x du equals 0. Now, all we need to do is distribute. This algebra, when we distribute, we get minus ux dx plus xu dx plus x squared du plus xu 3/2 dx plus x squared u 1/2 du, and that's equal to 0. Now these two will cancel, and then we can factor the du. If we factor the du, we get x squared plus x squared u 1/2 du plus whatever it's left. What's left? Just this one, which is xu 3/2 dx. That would be equal to 0. Remember, we're trying now. Now, according to the definition right here, it will be reduced to separable first order equations. So we're trying to separate the u and the x's. So how do we do that? First, we need to factor x squared. We don't want the x squared to be related to the u. So x squared factor of 1 plus u 1/2 du plus xu 3/2 dx is 0. Now move this part to the right side. So x squared 1 plus u 1/2 du is equal minus xu 3/2 dx. So I want to have all the u du on the left side and the x and dx on the right side. Remember, you can always move things diagonal. So let me first keep 1 plus u 1/2 du on this side, but let me keep minus x dx on this side. So all I need to do, move this to the bottom, so that would be u 3/2, and move this diagonally this way, and that would be x squared. Now, let me simplify this. This is divide by u to the 3/2. This will be u negative 3/2 plus u, what is that? Yes, 1/2 minus 3/2 is negative 1 du. And then simplify, cancel the x, you get minus x negative 1 dx. And we need to take the integral of both sides. Now this is going to be u. Negative 3/2 plus 1 is negative 1/2 divided by negative 1/2. Integral of u to the negative 1 is ln of u. This is minus, this is also ln of absolute value of x plus some constant. So let's just simplify it a little bit. This is the same thing as minus 2. Let me write this as minus 2 over u to the 1/2. Move negative 1/2 to the bottom. Plus ln of u equal minus ln of x plus c. Now I'm going to plug in. Remember the u happens to be what? The u is equal y over x. Remember, it's the substitution. Y is equal ux, so u is equal y over x. So now this is going to be minus 2 square root, this is y over x, plus ln y over x equal minus ln of x plus c. So how can I go further? This is the same thing as minus 2 square root x over y plus ln of y over x plus ln of x is equal to some constant. I mean, you can add these two if you want, so that would be minus 2 square root of x over y plus ln. If you do the product, y over, well, let's just do it, simplify the x. You can probably simplify this more, but I'm not going to go that far. This is good enough. And that's it for this example.